Hello, this is a small demonstration of a project that I'm working on, which is to control a modified Orion telescope, which has had some problems with the drive system on it. So the purpose of it is to control the altitude motor, which still works, via an Argo Navis, and some electronics that will then let the Argo track in altitude, so that it's a half push to scope. You still have to push to in Azimuth. So what we have is the project, which is this bit of electronics here, which has a PIC microchip processor on it, some relays, some PWMs, a 4x20 LCD, 4x4 keypad, and connected to that via serial we have our Argo Navis, and also connected to the Argo Navis we have an iPad with Sky Safari on it. That way we can still use the Sky Safari to be able to plan our evening of observation. Okay. Initially, when you are out in the field, you power up the project. Everything else is turned off, and we get Argo not connected, and it is in manual mode. We can now turn on the Argo Navis and set up our normal alignment or initial startup procedure. Turning it on. Initializers, we do our fix alt ref adjustment. It's now done, and we can then begin our alignment within the aligned star. Going back to our project, we then have connected the Argo, so we can say yes, the Argo is connected, and it comes up with unaligned. We're in alignment mode. We now align the telescope as normal. I don't actually have the telescope here, and so we're just going to do a dummy run. So two stars that I've selected are just Fomalhaut and Antares. The good thing about the Argo is it's very forgiving, so it'll actually stretch the sky for us to make sure we're in the right spots. So we're going to select Fomalhaut, which is located at 89 and 63. So 89, it's approximately there, and now we adjust our altitude to 63, and we do that using the project. We've got several rates of movement with the project. We've got some speeds here, so we can adjust our speed to the slower speed, or we can adjust it to X, which is the fastest speed. We also can, when in alignment mode, we have an S mode, which is a sustained mode, or we have a burst mode, which does a quick little burst, or sustained. You can also hold the button down so that it'll continue to drive the motor. So what we want is 63. So a little bit more, just rate down a bit. And 63. Near enough is good enough. So we've aligned on Fomalhaut. We go align, get our warp factor, and then we want to align on Antares. It's our second one. So Antares is at 258 and 33. So we'll adjust our azimuth to 258, which is going to be about there. And we want this to now equal 33, our altitude to be 33. So we go down to our tracking and we'll drive to 33. So that's on 45, so a little bit more. New mouse burst. 5. That's saying about 32. So we can go back the other way. Let's just slow our pace down a bit. Do another little burst. There you go, 33. So we go align Antares on 33, go enter, we are now aligned. And over on our project, it's saying we are on Antares. That's good. Now what we can do is normally you would take your Argo and you would go to your catalogue, bright star, let's align back again on Antares, and it tells us that we're to push 0 and to push 0, and it's slowly counting up 1, etc. So as you can see, it's starting to drift already because it's not a tracking telescope. If we then go back to our project, we're still in alignment mode on the project, but we then say we have aligned, so we press A, and that puts us now into tracking mode. And as you can see, it duplicates what the Argo says. It's got our guiding positions, it's got Antares, our current right ascension and declination, and then down the bottom we've got a few little boxes that tell us things. Now the first thing to notice is this one. This means that we're in manual mode, which means we can drive the telescope, or the telescope is being disconnected from the motor, so we can push it around if we need to. But we don't want to do that. We want to actually have the project track in altitude. So we do that by turning the tracking mode, well, we turn the mode onto tracking. And there we go. We're now in tracking mode, and as you can see, the altitude is going back, to 0, and then it counts up slowly for, when it gets to 5, it tracks, and it's back to 1. So down here we've got which way we're actually going to move, which way the drive is moving, and here we've got the speed at which it's moving at. We then can check on our Sky Safari, connect up to the telescope, and because it's not aligned perfectly, but there's Antares in the centre. There we go. There's Antares, there's our crosshair of roughly where we hope to have been pointing, but obviously it's not aligned perfectly. But as you can see, it's staying, it is tracking. On the Argo, we can drift, we can go move our azimuth back. So there's Antares there, you see it slowly drifts, and then click back, it tracks back into the centre of the eyepiece. And that's it there. Now, with normal Argo functioning, we can say, let's select a different object where we're going to guide to. Well, let's select M15. So we exit, go into our Messier catalogue, go to M15, and the altitude automatically guides. The altitude here is 00, so it is guided, but again the azimuth hasn't been moved, so we have to do that ourselves. Oh dear, oh dear. Get back down to 0. Bit too far. There we go. And then we look down here, and sorry it's a bit blurry, but that I can assure you is M15. Yes, it's not going to make the text any bigger. So there we have it. The project to drive a dodged up Argo, dodged up Orion, sorry, that never worked, but now we'll at least track in altitude and push to in azimuth using a little project. Thank you.